Synthetic division is a new way to divide those. Is it better? Is it worse? I don't know. You have to decide on your own whether you think it's better or worse. I happen to like it, but it is only useful in very specific situations. That's where we got to be careful. But yeah, synthetic division allows to divide polynomials using only coefficients. And remember, the coefficients, they're the numbers being multiplied by the letters. And it doesn't matter what the power of the letter is or what the degree of the term is. I guess that's the same thing. One thing we're going to need to remember with synthetic division is any missing degrees must be shown as 0 to whatever that degree is. Okay, so where we've seen before the difference of squares, such as 25x squared minus, let's say 49, for example, if that was being divided by something that where you were going to use synthetic division, you'd have to show the negative 49 like that, and then you'd have to show a negative x. Plus 0x on that. We need that 0th term, so any 0 terms need to be shown. And then the other thing it doesn't mention here is that the terms have to be in descending order. The degrees have to be in descending order. So in x squared, that'd be x to the 1th, then x to the 0th. And if there were more terms like something over here, maybe you have x cubed, and you can go as far this direction as you want, but pretty much we stop at the constant. So synthetic division just makes that pretty quick. So the next example that I'm going to do, when we get to the example, I'll show both methods, and then you can decide which one you like. From what I remember seeing, there's never a requirement that you use synthetic division that I'm aware of, which means it could be on the final, but I don't remember seeing it on the exams. This is how synthetic division looks. Okay, so if you have a polynomial like this one, you see it's missing a x squared term there. This is in descending order. It's just missing that x squared term. So you'd have to put in there a 0x squared. That's a 0. And in fact, that 0x squared is this 0. So you list all the coefficients, right? We don't really care about the degree of the term or the exponent of the variable. All we're looking at is the coefficients here. A, then B, then of course 0. I didn't use C because it was right here, but D and then E. You just list these in order, in descending order, for the terms. Okay, we don't really care if the coefficients are from least to greatest. Now over here, you see this is x minus E. You're going to have to remember that if it is something like x plus, I'll just say as an example, let's say it was x plus 10, right? That's not in the same form, x minus something, right? So you have to make this minus something instead. And to do that, you'd say, well, it's x minus, but then you'd have to make the 10 a negative 10, okay? It's kind of like that keep, change business maybe you've heard of. But adding a positive is the same as subtracting a negative if you end up seeing an addition sign somewhere in there, okay? And then, since you'd be subtracting a negative 10, that would be your C, and then over here, that's where the negative 10 would go. All right, now, the nice thing is here is the first coefficient just drops as itself. After that, then what you end up doing is you take that value, multiply it by what would be the C value, and then that goes here, whatever that is. Okay, and then if it were, let's say it was negative, then you do B minus whatever that number is to get this number here, some kind of number, and then you'd have that number. Then you just kind of repeat this process, multiply by that whatever the C is, and then that goes next. Let's see if I can put that in the right place here. Right there we go. Some kind of other number right there. Now that's not very specific, but this process just repeats over and over until you get to the end. And then right at the very end, once you get to this point, if there is a number there, that's your remainder. Let's look at an example. That should probably help. So I'm going to do this twice because doing it just once, not fun enough. So I'm going to take this polynomial here, and just like last time we saw, we're going to divide it by x plus 3. Now, of course, after this, I will use synthetic division, and then you can determine which of the two that you like the most. So the first thing we see is that we got an x to the power of 4 right there. And so what we'd have to do with the x, we'd have to multiply it by x cubed. X cubed times x is x to the 4th, which has been used. And then x cubed times the 3 would be 3x cubes right there, but we would take that away as well. All right, so that zeroes that out. As we've seen, as we planned, 2x cubes minus 3x cubes gives me negative 1x cubes. And then everything else just drops. And then we just continue. Well, again, we're just looking at the x. How many x's do you need for an x cubed? I'd say that you need an extra 2 x's, so that's x squared. But in addition to that, it's a negative 1, so we're going to have to multiply that by negative 1 as well. Negative 1x squared times x, that'd be, it's like we're taking away a negative 1x cubed now. Because you got the, oh crap. You have the x squared times the x, that's the x cubed. Negative 1 times, well, phantom 1, and it'd be negative 1, but that's what we're taking away. So then we got negative 1x squared times the 3. So again, that's in x squared, but you'd be taking that away as a 3x squared. So that would end up being 6x squared. I think I've given myself, no, I'm gonna run out of space. And then everything else drops because we just zeroed out that x cubed term. Okay, now that we got that, we say, oh, okay, we got those 6x squareds, right? So I will need another x there. X times x is going to be x squared, but I need six of them, right? So again, that's what we're taking away, those 6x squareds. That will zero out that term, but then I got 6x times the 3, that'd be 18x's, which we're taking away. So that zeroes out as planned. 26x minus 18x should be 8x's, and then the 21 just drops, positive 21. We're almost to the end here, but I got 8x's now, right? I'm just looking down here. So I've got an x already, I just need 8 of them. So I would need 8 of them there. Positive 8 times x would be 8x's, but again, that's something that we take away there. Then 8 times 3 there is going to be 24. Again, that's something that we're taking away. So it does exactly what we wanted. It zeroes out the x's. 21 minus 24 is negative 3. That's my remainder. I'll change the color just so we know it's a little different there. But you have your remainder, and you have your quotient here at the top.
This is what we did last week, right?
Yes, this is what we did last time. I did it again just to make sure you could remember how fun it was.
Is this coming in the exam?
So that was long division right there. But we have synthetic division, and whether you like it or not, because most people just don't like either of these, hopefully one helps you better than the other one, okay? So over here we say, look, it is x plus 3 right there. That's good. It's just remember that we need that what we're dividing it by to be in the form x minus c, right? So I don't want a plus sign between the x and the number. I want a minus sign. And just like we saw in that last example, that means that I'm going to make it x minus, we'll make it a negative 10 right there. Oh, I was thinking of the last example. It's a negative 3, thank you. So this, by the way, it's the same thing as x plus 3. I've just changed the format. And if I haven't said this before, math, if you can just understand that you can change the way things look without actually changing the overall value, you can do any kind of math, okay? And this is one way that we do this. Instead of showing it as x plus 3, since I'm using synthetic division, on the second method here, I need it to be x minus something, okay? And I can force that to happen, just like I just did. So with that then, I can see that the setup, right? Remember, you got kind of like a little box right here, and then down here we got some other values. But in the box is that c value, which for me right now, it's negative 3, okay? After that, now we need all of the coefficients of the values that are from the polynomial there. So the first coefficient of x to the power 4, there was a phantom 1 there, so I'm going to have to show that. So we listed the 1. The next coefficient is 2, and this is, again, this one's already in descending order. It's very generous of them. The next coefficient for x squared is 3. The next coefficient for x is 26. And then the final, you could say that's x to the power of 0 if you really wanted to, but the constant is fine, is 21, all right? So this is how synthetic division sets up. But the other nice thing about the setup is the first value automatically just drops as itself. Okay, no matter what, automatically drops as itself. And then, like I said, what we do is now what I'm going to do with that 1 is I'm going to take it, multiply it by -3, and that's where the next value goes there. So 1 times -3 is, well, that's where I put this -3 right here, okay? And at this point, it now reads 2 minus 3, which is -1. Now, if I had done this with a little bit more forethought, I would have made this purple and this one red, and then you could make your own comparisons to the values that we already have. But I forgot. So here we are. Now that I've got that one, though, I take my -1. I say -1 times -3. See if I can change that size there. -1 times -3 right there would be +3. I'll make that solid. Okay, and that's, since it's positive, it'd be in this line right here, it's 3 plus 3. And that would give us the next value, which is 6. So I got the 6th to line up right there.
That is way quicker.
It is, but it's not as fun. So, you know, you can still use it. I just, if you really want to have fun, you'll avoid it. So the next time, right? So I got 6 times the -3, and that will go to the next value right there. 6 times -3 is -18. And 26, that reads 26 minus 18, which is +8. Again, hopefully you're seeing the correlation, right, between the numbers that I have, even though my colors don't completely match, and the numbers that we had before. But now that I've got that, I've got my 8. I got to multiply it by -3. 8 times -3 is going to go right here. That's going to be -24. And, well, again, this last value right here, that's my remainder. 21 minus 24, last time I checked, that was -3. So this is our quotient, what I have there at the bottom underneath that line. And luckily we did some long division before this so we can see what the crap is going on, It's good to see the remainder, by the way, because we're going to need it. So I'm going to box that in. On the assignment, what's going to happen is some questions, that's going to be its own box. Some others, it's just not going to. It's hard to tell which it's going to be. Okay, so we know the remainder is -3 on this one, and that's great. I'm going to write it both ways, by the way, even though I've already written this part this way so far. And then everything else, I would kind of recommend starting here and then moving to your left, because remember, the number at this point is always a constant. The number in this position is always a constant, okay?
Can we do one ourselves?
Oh, yeah. I'll finish this one real quick, though. So that's always a constant, and then the next term has to be, this next one has to be an x term. The next one would be an x squared term, and then the final one here in the end is going to be an x cubed term. Now, the 6 there is positive, so I would just have a plus sign between it. The 8 is positive, so I'll have a plus sign between it. Where I have a -1 coefficient here, it's just minus, and it reads as minus. So this is my quotient, x cubed minus 1x squared plus 6x plus 8. But again, that's the same thing that we have over here. So that's one way to write it. Of course, the other way would have been to have it, see if I can do this right. Some stinking technology. So x cubed minus, and I am kind of simplifying. I believe on the assignment it will accept phantom ones, like I'm doing, or it may accept the ones that if you want to show them like I had originally. Plus 6x plus 8. And then if you want to add the remainder there, remember, just like we saw last time, I'm making it -3 over x minus, it was x plus 3. But just like we saw before, if you don't want it to be a -3, you can just make it a minus sign right there. It means exactly the same thing. And there we go. We kind of did that 2 full times, but I even wrote the answer out in three different times because it was so fun. Now, so yeah, that's a good question. When can we not use synthetic division? If I had a coefficient of x, it's done. I cannot use synthetic division. Now you could say, well, couldn't you factor out a value? You could. It's just you're kind of complicating things if you do, and I still don't think that you could. I'd have to think about that more because it's been a long time since I've done synthetic division. That tells you how useful it is. But it needs to be in this format, just x, right? That coefficient of x also, it needs to be a 1, a phantom 1 anyways. So here's this one. Okay, this one's a little different, a little, maybe a lot. Try it out though. Try it out. Take a minute to, and we'll go over this one. I will not use long division for this. We'll only be using synthetic division for this one. Although if you want to use long division, you can. All right, synthetic division then, right? Remember, we need it to be in the form x minus c, the divisor. That's what we're dividing by. So when that says the divisor, it's talking about this part right here. And it already is. It's x minus 4 in this case. All right, so when I set up my synthetic division, I'll try to give myself some space there, but the c value, which for me is 4, goes in the box. Now the thing with this polynomial that they've given us, it is a trinomial, but it's missing some values in the polynomial, right? So I'm going to rewrite it, but with the missing values. So I do have the x to the power of 4. That's good.
Oh, so it's 4.
All right, so the other terms that I'm missing, I know I've got a negative 63x and also a negative 6 there, but I know that I'm missing an x cubed term, so that's going to be a 0x cubed, and I'm missing also an x squared term, so that will be a 0x squared. It's kind of offset, sorry about that. But now those coefficients I'm going to list in order, right? Because we got the phantom 1x to the power of 4, so there's 1, and then I've got the 0 and then the 0, and then I've got the negative 63 x's, and then the negative 6 finally here at the end. So with synthetic division, we know that we just drop the first value, the 1, boom, there it is, excuse me, there it is. And then we take the 1, multiply it by the c value there, 4, and then that will go here, here. That's 1 times 4, by the way, which is 4. Now that's positive 4, right? So that would read 0 plus 4, which is 4. Now I've got 4 times 4 there, which is 16. That'll go in the next space there. And it's positive 16. So now I've got 0 plus 16, which is 16. Then I'll do 16 times 4, which is 64, positive, by the way. Positive 64. And I've got negative 63 plus 64, which is 1. And then I'll do 1 times 4, which is 4. That goes here on the end. And my 4, and then negative 6, that'd be plus 4. That'd be negative 2 there, okay? Now the negative 2, again, that last term there is always our remainder. And I'm going to write the answer in both ways just in case because it will ask for both ways on the assignment. But that last term right there, the 1 is always a constant. The 64 then has to be an x term. In fact, there we go. Which means the next term has to be an x squared, and then the final term there has to be an x cubed. The 4 is positive, so it'd be a plus between those two terms, and then the 16 is positive, so there's a plus there as well. So I have my polynomial, my quotient, with the remainder, but again, I'll write it a second way, with the remainder included in the polynomial. So that'd be x cubed plus 4x squared plus 16x plus 1. And then again, from here, it depends on how you want the negative. I'll just put the negative there in front. The negative 2 over the original divisor, which was x minus 4. So either one of these work. Again, I'm not even saying one's better than the other. They're just going to ask for one method. They're going to ask for you to show one way, and then you say, well, show it in a different way. If they say put the remainder in a different box, this will have its own box. Okay. But again,
When you say
on the assignment, what they're going to do is this will be a box right here, and then I think these are boxes, and these are boxes, and I think even boxes right here. Then you just got to fill them in, right? From what we had to start out right there. So I guess you could say they're forcing you to do synthetic division. All right, now to start this problem off, and yeah, we'll give you a shot at it. But just keep in mind that on these problems, you know, in the future, what they're gonna do is maybe just not say use synthetic division, they'll say divide. In that case, you gotta choose which one you wanna do, right? Do you wanna use synthetic division or do you wanna use long division? It doesn't matter which one you use. So this one, you know, it's leading just a little bit because it says use synthetic division, but just understand in the future, they may not say use synthetic division, okay? Yeah, take a minute or two and then try this one out. All right, so on this one, first thing I see here at the bottom, and again, first we were showing it needs to be x minus c, right? It's okay if the letters change. I really need you to be okay with the letters instead of them using an x that it's a t, right? But this one, I know, right? It's pretty rough. I make that mistake all the time where I just like using x's, right? This one though, it's a t value, right? Now this one starts as t. See, I almost did x again. It's t, but it's t plus 4. We need to be t minus something. So that's where we got to change the 4 into a negative 4. Now again, t plus 4, t minus negative 4. Are they different? No, they look different, but they're not actually different in terms of overall value, okay? Subtracting a negative is the same thing as adding a positive, which is what we have in both cases. So from that, then I can start setting up my synthetic division. I've got my box. And then we got the line that we're gonna use for operating, right? So I'm subtracting negative 4. That means a negative 4 goes in the box. And our polynomial was already in descending order, so that's good. And I don't see any t's that are missing, right? T squared, a t cubed, t squared, t, and then a constant. So we need all those coefficients. I've got a 1, phantom 1, t to the power of 3, so that's my first number. The next coefficient is 15. The next coefficient is 54. And then the final value there is 49. All right, now that we have that, we're ready to drop the first value, 1. And, well, you just take the 1, multiply it by the c value. 1 times negative 4 goes here, it's negative 4. Now this reads 15 minus 4, which is 11. Then I've got 11 times negative 4, which would be right here. That's going to be negative 44. And again, this reads 54 minus 44, which is going to be 10. And then we got 10 times 4, which is negative 40, which goes in our final spot there, negative 40. And 49 minus 40 is 9. Now that's my remainder. Everything else stays. I got the 10 there, which is positive. It's not an x term, but the 11 is. So I got a constant, then an x term, and then I've got a squared term, an x squared term. And the 11 is positive, so I got a plus sign right there. Now this is one way to write it. Again, this would be the quotient right there, which may be its own box on the assignment. The 9 could be its own box on the assignment. But again, perhaps it will want it the other way. So I'm gonna write it both ways on this one. Or you can have x squared plus 11x plus 10. That's a positive 9 over, again, our divisor there was, oh, I'm using t's again. See what I did right there? T plus 4. No, you did it right. I apologize. Yeah. I haven't talked about it. What the heck?
I'm like, for the first time I get something and I got it wrong.
Sounds like you may have got it right. Let's fix that. So that's a t. There's a t squared, t squared, and then a t right there. I guess I kind of caught at the tail end of that, but anytime's better than never, I guess. So I'll try to remember to put the y's in my answer. This one, though, comes as well, I'll make it y minus c scenario, right? It's just a y minus 1. The 1 there is the number that's going to go in the box for my synthetic division. There it is. Boom. I got it. So this one, again, if there was a plus sign, I would have made it minus negative 1. But since it's already minus 1, I just take the 1 there, boom, and put it in. And then we look at the polynomial in the numerator here, which is the dividend, if you care. But I got a lot of phantom 1s on this, right? Like, okay, so with the phantom 1s, that's good. I also see that this is in descending order. You got a power of 5, 4, 3, 2. There's a phantom 1, and then really it's y to the power of 0 there. But that's good. It's already in descending order. My first coefficient is a phantom 1, which I've now shown as 1. the next coefficient is, some students make this mistake with that y to the power 4. They just put a 1 right there. Don't forget the minus sign makes that a negative, because it is. It's negative. The next coefficient is positive 1. It was a phantom 1, but now I'm showing it. So I'm going to show that as positive 1. The next one is a negative 1. It's just kind of alternating there. Now I've got a positive 1 again. And then finally, for some reason, negative 8. I don't know why that's there, but it is. Lots of values there, right? We got 6 total values. 1, 2, 3, 4, 5, 6. That's because we had 6 terms in the numerator from the original dividend. Well, let's start dropping some values and multiplying here. So we drop the first value automatic. It just drops by itself. Then I've got 1 times 1, which is the next value. That's positive 1, by the way. So this is going to be negative 1 plus 1, which is 0. I need the 0 there, by the way. And now that I've got it, still you would say, well, you got to do 0 times the 1 there, which is going to give you the next value. 0 times 1, last time I checked, is 0. Now that'd be 1, I'd say 1 plus 0. You can say minus, it's the same thing. That's going to be 1 plus 0 is 1. Now we're going to take that 1 and multiply it by the C value 1. That's going to give me this next value, which is 1 times 1 is positive 1. And I've got now negative 1 plus 1, which is 0 again. Dang it. Or maybe not. But now, again, same thing. Multiply 0 times 1 is 0 right there. Again, you could say that's 1 plus 0, which is 1. Now I'll take the 1 times by the 1, which is going to be the final value there. 1 times 1 is 1. That better. And negative 8, that'd be plus 1, is going to be negative 7 right there. All right, now this is in order, even though we've got some 0 terms there, which I'm going to make that go away. Because we don't want 0 terms, by the way. I do have my remainder, and that's good. It's good to have a remainder. But from this, we know that the 1 there in orange, this one right here is just a constant. And then everything else, it just goes in ascending order now. It's x squared. This would be an x cubed term, and then finally an x to the 4th term, okay? Now again, just eliminating the 0 terms, I have x to the power of 4. Again, my next term is 0, and I did x's again. See, I did it. Should have been y's.
I did it too.
Yeah, so yeah, that next one, it was a positive. I'm making that a phantom 1. Hopefully that's okay. And then even the 0y, we're going to skip that one. So we do have the positive 1 right there. And then, of course, just like we have, the remainder of negative 7. Now, that's one way to do it. The other way is to write the remainder into the quotient. So y to the power of 4 plus y squared plus 1. Well, I'll make that minus 7 over the original denominator or divisor, which was y minus 1. I caught the y's earlier that time, so I feel better about it, but hopefully you catch it earlier than I did. All right, so this one does have the form x minus c right there. So when I set up my synthetic division, I know that I'll just put a 3 there in the box, okay? Then we're looking at all the coefficients. We got the x cubed, the x squared, the x, and then the constant right there. Well, from here, we know that the first number always drops, same as it usually always does. That 1 then we take and multiply it by the c value, and that would give us the value that goes right here. So 1 times 3 is 3. That's positive 3. So that would be negative 2 plus 3, which would be 1. And then same idea there. 1 times 3 is 3, and that goes in the next spot. There, 3. And then I got negative 1, that'd be plus 3, which is 2. Now I take the 2 multiplied by the 3, and then that number goes here. 2 times 3, though, is 6. And then last of all, that'd be 2 plus 6, which is 8. So our final answer then, right, we know the 2 is constant. The 8 is a remainder. And then we just tack on x's as we go. So that's a x squared. I'll rewrite it. We got x squared, we got a positive x, and then a positive 2 with a remainder of 8. Or if you want to write it, with the remainder in the expression, you'd have x squared plus x plus 2, and then the 8, which is positive, we just divide that by, well, we were dividing it by 4, the binomial there, x minus 3. So again, either one of these will do. Depends on what it asks for in the assignment, but just be aware, either way is usually good. All right, the remainder theorem. So the remainder theorem, I wish I knew how it applied or why it would be useful, but I can't. We're still going to use it though, okay? So that may not make sense right now. Just understand your remainder, it says P of C is the remainder of, or P of C equals the remainder. So that means that if your function was whatever it is, right? X, let's just make something up here. So if you're, I don't know, that's so thick, but so you got x cubed plus x squared plus 5. I don't care what it is. And let's say this was f of x equals this. Well, if you were for some reason wanting to divide this by, let's say, x minus 2 right there, right? The remainder of f of 2 would be the same as doing the long division here, or the synthetic division with, and then finding that remainder.
Right, with f of 2, you cannot do that.
That's true. What they'll say is, here's what they'll say. They'll say, using this function, use the remainder theorem to find this. And then what you do is you'd say, well, okay, that's fine, that's fun, because then I can use synthetic division again, and we love it so much. But then you say, well, I see it's f of 2 right there, so you put 2 in the box, and then your coefficients again. You got 1, 1, 0, and 5. I skipped some work there. Then you do some synthetic division. So 1 times 2 is 2. There's 3 times 2 is 6. 0 plus 6 is 6. 6 times 2 is 12. And then 5 plus 12 is, what do you know? It's 17, right? What it's saying is that if you were to replace these x's here with 2's, you'd get 17. Now, as awesome as that sounds, right? Like, wow, are you serious? I can do that with my life? Yes, you can. But in the past, we would say, just replace the x's with the 2,
Right.
and then be done with it. Unfortunately, or fortunately, however your perspective is, if they say use the remainder theorem, they want to see this stuff right here. F of negative 1. Now again, f of 0 and f of 1, all of these, I would just say, hey, let's just replace the x's with negative 1, 0, and 1, and then use the calculator from there. Which, if you do that, by the way, remember to, for your x squareds especially, put the negative 1 in parentheses. Otherwise, it's going to give you, it will give you the correct calculation, but you've told it to do the wrong thing, the calculator, okay? All right, well, to start us off here, we got a negative 1. Now, again, you could plug that in, or you could use synthetic division, which is what I'm going to do. So I've got my synthetic division. I'm going to do this fairly quickly, so just be aware. It's f of negative 1, so again, that goes in the box. Then I've got my coefficients of 3, negative 6, and 3.
I thought you said synthetic.
Okay, so let's get started here. We got drop the 3. 3 times negative 1 is negative 3. Negative 6 minus 3 is negative 9. Negative 9 times negative 1 is 9. And that'd be 3 plus 9, which gives me a remainder of 12. And that remainder right there is what f of negative 1 is. Boom. Now you can check, right? You could say, well, what is 3 times negative 1 squared minus 6 times negative 1 plus 3? It's going to be 12. You see, now you're like, oh, I'm now intrigued. I don't think you are, but you can say it. All right, so we're going to do this again, but now my C value is 0, so we put a 0 there, and that's okay. Same coefficients, though, of 3, negative 6, and 3. So again, we'll just continue here. We'll drop the 3. 3 times 0 is, 0. Negative 6 plus 0 is negative 6 times 0 is 0. 3 there plus 0 would be, 3. So f of 0 is 3. And again, if you come up here, you say, well, what if you replace the x with zeros? You get 3, and that one's a pretty quick calculation. Finally, right here in this one, we have an x value that's, or a c value that's 1. There's the 1. Same coefficients of 3, -6, and 3, but new calculations, right? So we'll drop to 3. 3 times 1 is 3. -6 plus 3 is -3. -3 times 1 is -3. Okay, I didn't expect that, but the remainder here is 0. So f of 1 would be 0, which again, if you replace these x's with 1s, you would find that it would be 0. Boom. And that is how you apply the remainder theorem to this kind of context. So the ones that we've done before, we could have done it like this. But I don't know if you wanted to do it now or then. So there we go.